universal coordinated time is based on both the components, and there should be equal time, मतलब the time should be same, it should be coordinated between these two. तो इसलिए कभी कभी once in few years the Earth's rotation would slow down a bit because of the various factors. So in order to compensate that, Earth को तो we cannot make it spin faster, है ना, तो that's fine. That's why we'll basically slow down atomic clock, है ना. गलती तो atomic clock का नहीं है, it's basically Earth's rotation would slow down, but in order to compensate that, we'll slow down the atomic clock. That is, that extra second which we should add to the atomic clock is called as leap second. Okay, I think many of the students are still confused about international date line. So what would happen if you cross the international date line? Let me just explain that again. Okay, leave about this. Let's assume that this is what is international date line. You are crossing the international date line either from west to east or from east to west. Then only the date would change, because this side it is all the previous date, this side it is all the next date. If you cross, you are actually coming from the previous date to the next date. If you are crossing from here to here, you are actually going back into the previous date, because all these parts of the earth are still in the previous date. All these parts of the earth are in the next date, because at one particular location we have to fix one particular longitude where the new date would begin. When the earth's rotation is taking as this as a standard reference point, तो यहाँ से हम यहाँ से cross कर दिया, so then it is said to be a new date is beginning. A new date would begin if the earth's rotation with respect to one particular axis, one particular point in the space is crossing the earth's 180 degrees, crossing this particular line, so the date is changing. That is what is international date line. So यहाँ से it's always the previous date. The date is, it's always behind, this is always ahead. But the time is same. Time is same only in this, if you take a location very exactly on the international date line. जैसे कि there is one island and there is another island, very narrowly separated, and both of them have chosen to be on this side. This island has chosen to be on this side of the international date line, and this island has chosen to be on the other side of the international date line. है ना, तो benefit loss कुछ नहीं होता, it's up to them. Because if you want to be on this side of the international date line, you can choose so, but you have to tell, पहले ही बोलना चाहिए, so that every world would know what is the date over there. है ना, तो I hope you are understanding this. What is the idea of international date line? This is where the new date would begin. This is where the new date would begin. This is island 1, this is island 2. Island 2 has chosen to be on this side of the international date line. जैसे कि many of the countries, USA, Mexico, Canada, and we have the South American countries, all of them, है ना, पेरू, चिली, जो भी सारा पैसिफिक ओशन का इस साइड में दिखता है, so all of them have chosen to be on this side of the international date line. Everyone are agreed, ठीक है, it's fine, कहीं पे तो शुरू होना है तो यहीं पे कर लेते हैं. And we have on this side of the international date line Australia, Japan, Philippines, है ना, and in between we have many islands. You can see छोटा छोटा islands है. This is Hawaiian Islands, है ना, this is Polynesia. If you can see, both these islands, Hawaiian group of islands and Polynesia, are very near. Time gap कितना होता है? Maximum it would be the time gap between these two, considering maybe 1 hour of time gap would be there. If it is 11 p.m. okay, sorry, 11 a.m. here, if it is 11 a.m. here, here it would be 12 p.m. because sun has already come here and then it is coming here. है ना, that is how we would see. तो यहाँ पर if it is 8 a.m. here it would be 7 a.m., 6 a.m., 5 a.m. So maybe here it is 12 p.m. Sun is vertically exactly on this point, but यहाँ पर it is still 11 a.m. So basically the time is very close between these two islands, but since they are separated by an international dateline, here the date would be different than here. Even though here it is 12 p.m., maybe if we are taking, let's say, Jan 26. If it is Jan 26 here and it is 12 p.m. here, what would be the date here? It is Jan 27. Because this has chosen to be on this side of the international dateline. But the time is very close, you can see. है ना? So I have chosen two islands which are separated by the time gap of 1 hour. Here it is 11 a.m., here it is 12 p.m. सुबह 11 बजे 12 बजे. But since this island is on this side of the international dateline, it is Jan 27, and this island is on this side of the international dateline, it is Jan 26. तो यहाँ पर Jan 27 कब होगा? When the sun passes all through this and comes back here again, then it is Jan 27. तब यहाँ पर Jan 28 हो जाएगा. Just because it is on this side of international dateline. International dateline is, date itself is imaginary concept. है ना, for our reference. So now tell me, if a person is crossing from this island to this, Hawaiian island से यहाँ पर Polynesia आ गया है. A person has crossed from this island to this island. So he was in Jan 26 and now he is in Jan 27. What exactly is it's happening? He is losing a day. You might ask, Jan 26 से Jan 27 आ गया तो कैसे losing a day? Because his entire day of Jan 26 is lost, गायब हो गया. He was at 12 p.m. Jan 26 here. पूरा Jan 26 बचा था ना, 12 p.m. के बाद में जितना टाइम है वो पूरा बचा था, and next day till morning 11 a.m. तक टाइम था. Now suddenly he is here. He is in Jan 27 11 a.m. So basically he has lost the time. The time in his life is gone. It will not come back. The time is lost. So if at all he has jumped the international dateline and it has come to this side. Suppose if he is crossing this from this side to this side. Here it is Jan 27 11 a.m. ऑलरेडी रिपब्लिक डे सारा सेलिब्रेशन खत्म हो गया है ना. ऑफ कोर्स लेट्स अज्यूम दैट ही इज एन इंडियन, तो ही सेलिब्रेटिंग एट हिज होम. पूरा Jan 26 छुट्टी मना दिया, तो यहां पर आके देखता अभी भी Jan 26 है, सो ही इज गेटिंग अनदर रिपब्लिक डे. So even though in his calendar he is subtracting a date, he is actually gaining a day. He is getting another Jan 26 to spend over there. I'll take another example. Let's say there is only one single island. But this island has accepted, ठीक है, we don't want to make the international dateline crisscross, let it pass through. Whatever the areas on this side of the island, they would have the next day, and on this side of the island they will have the previous day. है ना? So here it is Jan 1st morning 7 a.m. The time is same because it's in the same longitude. Agar if it is morning 7 am, here also it is morning 7 am. Is that right? Time तो same ही है. Time is based on the longitude only. इसमें तो change नहीं होगा. But 7 am what? 31st December, because it is on this side of the international date line. So if you are getting up morning 7 am 31st December, you would have the entire 31st December to spend. पूरा पार्टी करने का प्लान होता है. तो यहां पर if the same person is here, he has already celebrated his 31st December. पूरा न्यू ईयर का पार्टी खत्म हो गया इसका. He is on the New Year day already. Let's assume that he is in 31st December morning 7 am. है ना, गलती से ऐसे क्रॉस करके इस तरफ आ गया, धक्का देके इसको पुश कर दिया इस तरफ. You will come and see here it's 7 am Jan 1st, 31st December गायब हो गया. Like it's 31st December is, it's lost in his life. है ना? So that is what is, he is losing a day. If you are crossing from east to west, you are losing a day. The same person, he has spent the entire 31st December and he has come back here. He is still having 31st December, एक और 31st December मिल रहा है. So keep this in mind if you want to surprise any of your beloved one. तो ऐसे celebrate कर सकते हो, दो 31st December मिल जाएगा आपको. But ऐसे तो नहीं होगा, it's difficult. Same island, तो none of the islands have chosen, so it's basically like that. Like if you have to do that, you will have to cross from one island to another island in the Pacific Ocean. So that is what is losing a date and gaining a date. Losing a day, gaining a day. I hope it is clear. I have explained in detail now. Then we started with universe, है ना, and the different theories of origin of universe. I told you there are three theories which mainly talks about the origin of universe: steady state theory, pulsating theory and Big Bang theory. Steady state theory by Hoyle and pulsating theory by Arthur Eddington and Big Bang theory by Georges Lemaitre. So steady state theory says that the entire universe is always constant, but it doesn't say that it is stationary. There is a difference between saying constant and stationary. Okay, if I am saying, many of you got confused yesterday itself. If I am saying that the universe is constant, it doesn't mean that it is stationary. Constant in its size, constant in its mass. Constant मतलब जितना size है उतना ही रहेगा. But it is not stationary, it keeps moving. So here comes the trick. This theory, it assumes that there is a boundary for this universe. Beyond that boundary, if whatever the stars are moving out of this boundary, it becomes unobservable and we don't call them as universe. यही तो major गलती है. Okay, how can we set only this much is universe? Beyond that, what would happen? He has not explained this. So basically he says this entire universe is constant in mass and size, but at the same time it is constantly expanding. Okay, it is constantly expanding at the same rate in which the stars are becoming unobservable. In the same rate, new stars are getting created. That is what is steady state theory. The universe has always remained steady. Okay, there is no beginning, there is no end. That is what is steady state theory. Second one is pulsating theory. Pulsating theory basically says that universe continuously undergoes contraction and expansion. Contraction, expansion. ऐसे चलते रहेगा. And contraction is because of gravitational pull. Expansion is because of explosion. And it says that we are currently in explosion. And the third one is Big Bang theory. Big Bang theory was proposed by Georges Lemaitre in 1927, and as per the Big Bang theory, the Big Bang theory says that before 13.7 billion years everything in the universe was together in a single point, in a very highly compact, dense and hot point which was called as singularity, and this singularity exploded. It underwent cosmic explosion, and this cosmic explosion led to the expansion of the universe. From here it started to expand, and during that expansion everything got created, from elements to atoms, atoms to gaseous molecules, molecules to gaseous clouds to stars, stars to galaxies. And this is still expanding. The stars and galaxies are still expanding. And who gave the proof for that? It was given by Hubble. Okay, basically he was observing the light coming from the stars, and he observed that these light from the stars are undergoing redshift. So that is a clear indication that the stars are moving away. Okay, it's similar to the principle of ये जो Doppler effect होता है sound का, you might have heard about this. If an object is coming towards you, the sounds, you will hear the sound louder. If an object is going away from you, you will hear it in a lesser amplitude. है ना, उसका voice कम होते जाएगा. In the same way, if the object which is emitting light is coming towards you, the light which is being emitted will become red, will become bluer. Okay, it will appear bluish. It will shift its wavelength in the entire visible light spectrum from different colors, okay, towards the blue end of the spectrum. If the object is moving away from you, it will shift its light towards the red end of the spectrum. That phenomena, it's a characteristic of the moving body. So that phenomena is called as redshift. So by observing the redshift in the light which is coming from the stars, so Hubble said, the stars are moving away from us. So that is actually the proof of Big Bang, which is basically explosion had happened, isliye all the objects in the universe are moving away, that is stars and galaxies are moving away. And the rate of expansion is called as Hubble's constant. Then I told you about the life cycle of star. So life cycle of star talks about how the stars originate, so life cycles talks about how the stars originate, starting from stellar nebula. Stellar nebula is basically gaseous clouds. From where the molecules inside the gaseous clouds will start to collide with each other because of the gravity, and that collision releases energy, and gradually it releases heat, and that will lead to the formation of a hot core. At that point of time when it forms the hot core, it is called as protostar. And protostar, when the temperature increases to sufficient extent, that is 15 million degrees Celsius, it becomes a star. That is when the nuclear fusion reaction starts at the core. And when its entire fuel, major part of the fuel is over, the star starts to increase in size. The size of the star starts to increase because of expansion in the outer shell. The reaction is now happening in the outer shell, but at the center there is some kind of contraction because of heavier elements. Majorly it would have iron core hota hai. That is what we call it as red giant. And after some time this entire body would collapse with a small core and entire shell of gas, which is called as planetary nebula. And gradually this shell of gas will be washed away, that will disappear, leaving only the white core, which is called as white dwarf, and it will become black dwarf. later. If the size of the star is less than 10 times the size of sun, this is the life cycle. If it is more than 10 times the size of sun, जो हमारा सन है, sun is our star, okay, sun is not any star, sun is solar system का जो हमारा star है, that is what is sun. If it is more than 10 times the size of sun, it will become a massive star, and massive star will become a red supergiant, and red supergiant will lead to supernova explosion, where it will explode. Even after the explosion, whatever the core is left, if it is still more than 3 times the size of sun, in that case the gravity will be very, very high. It becomes a black hole. If it is between 1.4 to 3 times the size of sun, it becomes a neutron star, which is a body made up of closely packed neutrons. So this is life cycle of star. You don't have to go into too detail about this, just remember the different names, different terminologies. Detail में questions नहीं आएगा, and you don't have to expect mains question here. It will be mainly prelims question. Okay, for your understanding we might ask you to write about this in your assignment, वो अलग बात है, but mains में UPSC mains में तो इसका question नहीं आएगा. So they might ask few simple questions on prelims pattern. So then we saw the different types of galaxies. One is elliptical galaxy, which is almost spherical or oval in shape, where the stars are uniformly distributed. Then second one is spiral galaxy, okay, which is with a spiral bands, and from the side view it appears like a flat disc with a bulge at the center. And third one is irregular galaxy, and our galaxy, that is Milky Way galaxy, is an example of spiral galaxy. And I also showed you a beautiful video showing our Milky Way galaxy. So any doubts here till now? Dhananjay is asking, sir, in exam how will we be aware about the location of different places like London, Johannesburg, Japan, Hawaii with respect to international dateline? So why do you want to know with respect to international dateline? Q? Why do you have to know about that? You will have to know where is London, where is Johannesburg, where is Japan. So that one we will cover, the important locations we will cover in the class, mapping mein. With respect to international dateline, you don't have to remember every location, zaruri nahi hai. Unless if some of the countries changing, shifting from east side to west side or west side to east side, which happens once in a while. Okay, last one happened I guess in 2010, 2008 में हुआ था, I guess Kiribati Island, ऐसे कोई था. It was not important, बहुत पहले था. So you don't have to remember the location with respect to international dateline. Only thing which you have to remember is Bering Strait. Bering Strait is that water body between the Russia and USA, which we will cover in the mapping location. Through that Bering Strait, the international dateline would pass. Other than that, you don't have to remember everything. Any other doubts? So next topic, twinkling of stars. So let's see how many of you will answer this. I have a question. Why does the stars twinkle? We have heard about this, twinkle twinkle little star. How I wonder what you are. है ना? So why does the stars appear to be twinkling, whereas the planets do not twinkle? If at all you have observed any of the planets in the night sky, if you are lucky enough to observe that light pollution इतना है cities में, तो it is very difficult to see any stars live about the planets. So if we observe, few of the bodies in the space do not twinkle, few of the bodies twinkle. Twinkling bodies are majorly stars only. Okay, all of them are stars. So planets do not twinkle. What is the reason behind this? Let's see how many of you will answer this. So send your answers in queries. So the question is, why does the stars twinkle and not the planets? Taruna is saying refraction of stars light. Okay. So why does the light from the planets do not undergo refraction then? So Yashvardhan is saying due to the phenomenon of scattering of light. ठीक है. So why not planets? Why not the light of planets do not undergo scattering? क्यों नहीं हो सकता है? Why only stars? Okay, Mahak is also saying refraction. ठीक है. Whether it is refraction or scattering, whatever you are telling. My question is, why only stars? Why not planet? Think. So the idea is to make you think. है ना, तो you can understand better. Start to think. Sahil is also saying the same. The rays coming from star filtered through different layers of the atmosphere appear to be twinkling. Good. You have explained well. When it passes through different layers of the atmosphere, it appears to be twinkling. ठीक है. But why not planets? Anyone? No one? Okay. So you are able to answer only half of the thing. Yeah. So here you can see, so we are standing here on the surface of Earth. This is the surface of Earth. And now we are standing here. We are seeing the light from a star. So Arpit is saying planets do not have own light as their heat is cooled off. No. Light is light, whether you are giving the reflected light or your own light, तो इससे फर्क नहीं पड़ता है. Let me explain. If you are viewing this star from the surface of Earth, the light coming from the star passes through different layers of the atmosphere. Atmosphere has different layers. When it is passing through different layers, it undergoes bit of scattering. Even though the light is coming in that direction, थोड़ा सा ऐसे इधर उधर देख के आता है, because of the various particles which are present in the atmosphere. And by the time it reaches our eye, so we see that the light is not coming in a straight line. है ना? So because of this we think that the stars are twinkling. But any planet which is near to the earth, है ना, even though in the sky we won't be able to see the difference in the distance, but the stars are located at very long distance, बहुत दूर है, millions of kilometers, they are located in very very long distance, but the planets are very nearby. The light which are coming from the planets, of course this light is not their own light, it is the light from the sun, है ना, सन से जो लाइट आ रहा है उसको रिफ्लेक्ट कर रहा है, यहां से सनलाइट इज कमिंग एंड इट इज रिफ्लेक्टिंग इट बैक हियर. बट दिस लाइट विच इज कमिंग फ्रॉम द प्लैनेट्स is not coming in a single ray of light. The light which is coming from a star, even though it is a huge body, huge size body, but for us it is just a single point. It is just a single point. It's just a dot. वहां से जो light आता है, it comes as if it is just a single ray of light. बहुत छोटा सा, very very narrow beam. And if narrow light is undergoing reflection, our eye can easily notice this. But the light which is coming from the planets are very near, and this is not a single ray of light. It comes as a narrow, it comes as a wider beam of light. जैसे टॉर्च लाइट जैसे आता है, you can see that the torch light, it appears, it comes like this, and of course even this light also undergoes the scattering, but not the entire beam would undergo the scattering together. So if one ray of light is undergoing scattering, there is another ray to compensate that. If this is undergoing scattering, there is another ray to compensate that. है ना? So the scattering effect which is on this light which is coming from this planet is very very less compared to the scattering effect which is coming from the light of a star, because star's light is coming from a very long distance, बहुत दूर से आ रहा है. By the time it reaches earth, बहुत कम light बचा होता है उसके अंदर, very very small amount of light, it's almost like a single ray of light. It is very easy to undergo that scattering, but this light which is coming from the planets are not like single ray of light, it's a beam of light. In that there would be multiple rays of light, बहुत ज़्यादा अंदर रहता है. So even if one component is undergoing scattering, another component would compensate for this. So we won't be able to see that scattering. Our eyes will not be able to perceive the scattering which can happen inside this beam of light, and we can easily perceive this in the light which is coming from the stars. So that's why none of the planetary bodies in the solar system, that is all other planets, all other satellites, do not twinkle, but the stars always twinkle. So basically it's because of the atmosphere. So that means सपोज इन द नियर फ्यूचर हमारा जो SpaceX है, एलोन मस्क का, ही इज मेकिंग द स्पेस ट्रैवल कमर्शियल, एंड इफ यू आर एबल टू visit our international space station. We have international space station, you know that? International space station is something like a huge platform which is rotating on earth. बहुत बड़ा platform है. It is rotating on that. People are there, astronauts are there. His plan is to commercialize this space travel, and if you get an opportunity you can go visit that. So if you get an opportunity and if you go visit that, one side you will see the planet Earth, on the other side you will see a very beautiful sky with completely dark and only stars, and none of the stars in the sky viewed from the space do not appear to be twinkling. The stars viewed from the space do not appear to be twinkle because there is no atmosphere over there. It is not passing through any atmosphere, so that scattering is happening. So basically stars appear to twinkle only if you are viewing it from the surface of Earth. So write about this twinkling of star. Due to the turbulence in the atmosphere, the light coming from stars are more deflected as it appears to come from a point source. It appears to come from a point source, and that is from a single point the light is coming. So that would be a very narrow beam, very narrow beam of light. It appears to come from a point source. Full stop. However, the light coming from different planets of the solar system is not from a point source, and do not get deflected very easily. Full stop. That is why planets do not twinkle. Full stop. And twinkling is not observed in the space. Twinkling is not observed in the space. So next one, light year. You might have heard about this light year. What is light year? Is it the measure of time? The time taken by the light, do we call it as light year? No. Light year is the measure of distance. Okay, it is very easily, it can be confused. We are saying light year, so maybe this is a type of year. No. Light year is basically the distance travelled by the light in 1 year. It is the distance. Okay, it is a measure of distance. You can imagine what would be the speed of light? 3 into 10 to the power 8 meter per second. 3 into 10 to the power 8 meter per second. Okay, 3 ke aage you have to put 8 zeros. So that much of meters per second, that is the distance travelled by light in 1 second. So in that speed, if light is going for 1 year, pura 1 year, if it is just travelling in that speed, so how much distance it can travel? That distance is called as 1 light year. And in this speed, do you know how much time the sun's light take to reach Earth? Even in this speed, even with this high speed, the sun's light will take 8.3 minutes to reach Earth. It takes whatever the light we are seeing from the sun, it is released from the sun 8.3 minutes ago. So basically, if sun suddenly stops giving out light, है ना, we will see the darkness after 8.3 minutes. है ना, तब तक वो पहले 8.3 मिनट्स के पहले जो लाइट प्रोड्यूस हुआ था वो आता ही रहेगा. Okay, that keeps coming. So this is the time taken. So you can imagine the distance between the sun and the earth. And in that speed, if the light is traveling for 1 year, so that is what we call it as light year. So this is the measure of distance which we use to measure the distance between different stars. The distance between different stars are measured in light years. So what is constellation? Constellation, you might have heard about this. If at all any of you have tried to observe the stars in the sky, and if at all you have tried to observe the stars in the sky, there is some kind of recognizable pattern. And you might ask how this pattern is we are able to observe, because the stars are moving away from each other. I have already told you stars are moving away from each other, but at very, 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 very slow rate. It is not that easy for the human beings to observe that. So practically all the stars in the sky appear to be stationary. Okay, they are fixed. So since they are fixed, we can see some kind of patterns. है ना, तो पुरानी olden days, the Stone Age man, after that, before the civilizations developed, cities developed, man became unnecessarily busy. है ना, so we became unnecessarily busy. That too after the advent of our mobile phones and all. So फालतू में busy है. Swipe up, swipe down, swipe up, swipe down. तो इसी में पूरा रात चला जाता है ना. So we won't get time to come out and see the sky, night sky, the beautiful sky. So earlier days people used to come out and see, they used to try to imagine what exactly is there in the space and how the things would be and all. So that time they recognized there are certain fixed patterns which you can see and fixed shapes. Many of the times these shapes resembled some animals, है ना, जैसे stars. Okay, so they recognize different stars. तो उसको join कर दिया ऐसे, just writing. One of the very famous one, Big Dipper. है ना, it appears like kite. Big Dipper. So we also call it as Saptarshi Mandal. है ना? So these recognizable pattern which we can see in the sky, night sky, is called as constellation. What is constellation? You can write the group of stars forming a recognizable pattern in the sky is called as constellation. Here you can see this is what is Big Dipper, है ना? It is made up of 7 stars which is always, their position is always fixed, it will not change. We also call it as Saptarshi Mandal. So now we have the concept called pole star. See, Earth is not stationary, है ना? The earth is not stationary, earth rotates. As the earth rotates, for a person who is on the surface of earth, he will not be able to recognize its rotation. But he will see that all the space surrounding the earth is rotating. If we have a sun here and if the earth is rotating, we won't see if you are standing on the earth, we won't see that we are rotating. We think that the sun is rotating around that. ऐसे दिखता है ना, because as we are moving in this direction, sun appears to be moving in this direction. So that's why we say, because the earth rotates from west to east, we think that the sun rises in east and sets in west. Because earth is rotating in this direction and sun is moving in this direction. It applies the same for all the stars also. All the stars, like it is making a huge three-dimensional space surrounding the earth. And a huge three-dimensional space, in that we have huge number of stars. Since the earth is rotating, for the entire night duration, this position of the stars also keep changing. And if we have earth here, suppose let's assume that this is earth. है ना? So this side, ये जो dark side है, this is night and this is daytime. I hope you can imagine this. So we are on the dark side, we are seeing the stars. यहाँ से तो यहाँ से sunlight है, यहाँ से sunlight नहीं है. So we are able to see the stars. But the stars are all stationary in this side. पूरा stationary है. It's all fixed in the sky. But whatever the pattern which we see, we keep moving. है ना? We keep moving like this, but we think that the stars are moving like this. So basically all the stars in the space appear to be moving all over the night. If at all you have observed the night sky, you will see that the stars position, they are not fixed, they don't appear to be fixed. यहाँ पर जो हमारा बिग डिपर है, so if sometime it is here, it would come back here. यहाँ पर ऐसे आ जाता है. After some time it would be like this, and after some time it would be like this here. The entire stars appear to be moving all through the night. So basically all the stars in the sky appear to be moving all through the night except one star in the sky. This star don't appear to be moving at all. It's always stationary. All through the night it's in the same position. So that star we call it as pole star. And you might ask why this doesn't appear to be moving. क्यों नहीं ऐसा नहीं होता है? Because this pole star is located exactly above the North Pole. It is located exactly above the North Pole. And why all the other stars appear to be moving? Because it is rotating body. But if you take this as a standard reference point, the North Pole and the South Pole, जो भी object इसके ऊपर है, so that will never appear to be moving. You observe this object from here, it's always stationary. You see it from here, you see it from here, it's always stationary because that is located exactly on the rotational axis. And it is exactly located on the rotational axis, which is always fixed. Why we have kept North Pole and South Pole? These are the stationary points on the surface of Earth during its rotation. During its rotation, all the parts of the Earth rotates. Equators, tropics, temperate regions, सारा rotate होता है, but poles will never rotate. It's a single point. है ना? You stand on the pole with 24 hours, you are not rotating, you are actually stationary. So जो भी the points which are located on above this appear to be stationary from any point of the earth. So basically we have two stationary points. One is North Pole, another one is South Pole. So whatever the stars which are located above these poles do not move all through the night. They always appear to be stationary. That is what we call it as pole star. So this is the time lapse image. You know what is time lapse? You record the entire night sky, है ना, एंटायर नाइट स्काई को एक ही पिक्चर में रिप्रेजेंट करना है तो ओवर द एंटायर नाइट. So this is how it would look. All the stars appear to be moving. Of course there would be many stars which goes below the surface also, क्योंकि they are located near to the equator, okay, above to the equator. But one star is always fixed in the sky, that is what we call it as pole star. It will never move, its position is always constant. So our people use this pole star to find the direction, because pole star always indicates north. It is exactly above the north. So you observe the night stars for longer duration, you will see only one star not moving, and that direction, in whichever the direction it is, that is what is your north direction. It is very easy to identify the north direction. तो if at all you are lost somewhere, night में कुछ भी नहीं दिख रहा है, you keep observing the night sky. Only one star you will see that it is not moving, and that star is pole star. You might ask how to identify, कैसे देखते, कैसे रहना है, कैसे पता चलता है. ठीक है, एक ही स्टार को वो आइडेंटिफाई नहीं कर सकते, ठीक है, I agree. So for that there is a shortcut also. You can identify this Big Dipper, 7th star, तो ये तो पता चल जाएगा, है ना, the 7th star. The top two stars, imagine a straight line between these two stars and extend this straight line continuously till it meets one of the brightest stars in the sky, and at least observe this for some time. After some time this would have come here, and after some time this would have come here, but still it forms straight line. Okay, ऐसे आता है, it would be something like this. And here can you see it is again straight line. After some time this would come here, but still you can connect it with a straight line. So in order to identify the pole star, locate the Big Dipper or Saptarshi Mandal, you will be easily able to recognize the pole star. Okay, what is pole star? It is a star in the sky which never moves, or appear to be, because all the other stars also do not move. It's basically they appear to be moving. But the angle at which this star is visible from any particular place depends upon the latitude. I told you this star is fixed in the sky. I did not tell you that it is visible always in that same angle from all across. If at all you are viewing this from this particular point on the surface of Earth, let's assume that this is 50 degree north. You view this at this particular angle in the sky. From the surface, okay, it is maybe at 40 degrees angle. You view it from here at 70 degree north latitude. From the surface, okay, from the surface you can see this is at an angle of 70 degree, okay, this is 50 degree. Can you see from here, Sunny, that pole star is at 50 degrees. You go to the higher latitudes, the pole star is at 70 degrees. You stand exactly at the north pole, pole star is 90 degree, है ना? तो try to imagine this. The position of the pole star is always constant in the night sky. It always stationary in the night sky. It will not change in the night sky. But the angle at which this pole star is visible would vary from one latitude to another. The angle at which pole star is visible from the pole is 90 degree. The angle at which the pole star is visible from the mid latitude is lower angle. Okay, at 50 degree north latitude you stand, it will be visible at 50 degree north, 50 degrees only. You stand near to this 20 degree north latitude, from the surface it is visible at 20 degrees only. What about equator? It is visible at 0 degrees, if at all you can see. बहुत rare chance है, बहुत rare chance है. Where maybe in the oceans, maybe if the sky is clear, because it is very difficult to observe the stars at 0 degree. So what about all these locations below the equator? They will never be able to see the North Pole star. All these locations below the equator, they will never be able to see the North Pole star because that is on the below the horizon. So that's why the North Pole star is always visible only from the northern hemisphere. We also have a South Pole star, which is located exactly above the South Pole. It is called as Sigma Octantis, the name of the South Pole star, and the name of the North Pole star is called as Polaris. North Pole star is very easy to identify because this is it is one of the brightest stars in the sky. South Pole star is not as bright as the North Pole. So basically if you are in any part of the southern hemisphere, still one star is completely constant, it is not moving at all. So that is what is Sigma Octantis. It is difficult to identify this, but North Pole star is easy to identify. Is that clear? So basically the angle at which the pole star is visible in the sky increases from equator to pole. At the equator it is visible at 0 degrees, at the pole it is visible exactly at 90 degrees. And now why it is stationary? The simple logic is it's stationary because Earth rotates, it appears to be stationary. In fact, all other stars are stationary only, but we don't see it stationary because we rotate. You can write pole star. What is pole star? Star which is aligned with the axis of rotation of Earth. The stars which is aligned with the axis of rotation of Earth is called as pole star. In the northern hemisphere, we have North Pole star, which is called as Polaris. And in the southern hemisphere it is Sigma Octantis. sigma octantis. Full stop. A pole star always appear to be fixed in the sky. However, the angle at which it is visible in the sky, increases from equator to pole. That is pole star. So we have few queries. Tushar is asking, does the constellation not move if the universe is expanding? Exactly, यही तो बोला था. Where were you when I was telling about this? I told you constellation do not appear to be moving because the distance between the different stars at rate at which it is expanding is very, 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 very slow, and the stars are located at very far distance, इतना दूर पे है. Even if it is moving faster, हमें पता ही नहीं चलता है. It is not observable by the human beings. The rate is very slow. The rate at which it is expanding is slow, and because of the distance, it is located at so far distance. Even if it is moving, हमें पता नहीं चलता है. That's why we always take it as a fixed source. Tushar, you are asking again, please elaborate why light coming from the planets do not get deflected in the atmosphere. Okay, I will tell you another way you can imagine by yourself. Okay, you might have this laser light. You might see that laser light, जो toy light आता है ना, it goes a single point. कितने दूर तक होगा? Like it goes up to like maybe half kilometer. A good laser light. Not exactly laser light, जो pointer device जो आता है. Like this, like we have a pointer device in this also. Okay, this is not visible here. Okay, it's a pointer device. It will point. Fine. So you take a laser light and you turn it on and let it pass through different layers of paper, and try to observe it from the other end. Let this be done by another person. Okay, give it to your friend. Let him turn on the laser light. So let it pass through different layers, the plastic layers you can say. Now if you observe it from the other line, if it is passing through different plastic layer, transparent layers, so you can see that the light will not come in a straight way. It appears like a twinkling. Okay, थोड़ा सा बहुत deflect होके आता है. Okay, in the same place you give a torch. Torch का light कैसे आता है? It comes like a beam, है ना, पूरा ऐसे आता है circle shape में. It comes as a beam. The same beam, even though it is passing through the different layers, transparent layers, it is very difficult for the entire beam to be deflected. पूरा बीम को ऐसे डिफ्लेक्ट करना मुश्किल है. तो इसके अंदर there would be multiple rays of light. So few of them would get deflected, few of them will not. When few of them get deflected, the other rays of light will compensate that. So for a human eye, which is not that sensitive to observe that much of deflection, we will not be able to observe the deflection which is happening in the ray of light, the beam of light which is coming from the planets. The light from the planets do not come from a point source, it comes from a circular source like this. The entire surface is emitting light. But light from a star appears to be coming from a point source. Only a small point is emitting light. तो यहाँ से तो ऐसे आएगा light, यहाँ से ऐसे आएगा light. So which one undergoes easy scattering? Obviously जो पतला है, this one undergoes easy scattering, not this one. Sushant is asking, there will be dust in the space. कितना dust होगा भाई? It will be very very less compared to the thickness of atmosphere. Can you imagine thickness of atmosphere? It's so thick, so heavy. All the gases you can imagine. Okay, that too in the lower atmosphere, 8 kilometer, 10 kilometer में तो maximum 90% of the atmosphere gases are there. है ना? तो maximum thickness is there. Compared to the thickness of the atmosphere, the mass of the gases in the atmosphere, dust which is there in the space is very 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 negligible. That is not enough to cause any kind of deflection. Not possible. So there was a question in UPSC on this pole star once. एक बार क्वेश्चन आया था. आप इतना डिटेली जा रहे हैं तो let me show how the UPSC asked the question. This is very important to understand the type of question UPSC asks in this context. Can see a person stood alone in a desert on a dark night and wanted to reach his village which was situated 5 kilometers to the east of point where he was standing. He had no instrument to find the direction, but he located the pole star. The most convenient way now to reach his village is walk in which direction? Let's see how many of you will be able to answer this. Okay, give your answer in the queries. This was a question asked in 2012. Let's see who will give the right answer first. Batch coordinator, please post the answers in a sequential manner. Whoever has given the answer, post everything. Let's see how many of you will be able to give the answer, and let's see who will give the right answer. Okay, we have 4 answers till now. Only 4. Okay, 5. 6. 7. 'Let's see how many of you out of 10 would be right. 8. 9. 10. Okay, good. तो क्लास का थोड़ा तो यूज हुआ है मतलब. So only 2 out of 10 are wrong, and the first right answer was given by Sahil. Good. You have to be this quick in the exam. ठीक है, बस. So almost all of you have given the right answer except few. Not that difficult, yeah. Like I told you the concept of pole star. So what is pole star? Pole star, if you are able to identify the pole star in the sky, it gives the direction of north. Suppose there is this person who has lost his way. Okay, he has lost his way. So basically he just have the information that yahan se if he goes towards east, he walks east for 5 kilometers, he will find this village. He doesn't know which one is east. It can be in this direction, it can be in this direction, it can be in this direction, it can be in this direction. पूरा dark है, पता नहीं चलता है ना कहाँ पर east है. तो basically he has to identify which is east. If he gets east, he will just walk straight. He will, if he walks for 5 kilometers, he will reach the home. For that he has to identify. It is difficult to identify east, but he can identify north in the night sky. कैसे? You identify the pole star, you will find the north. He will be able to find that there is this pole star. So now he has got to know that this is pole star and this is north. So this should be east. So how does he should walk now? He should walk towards the east. That means keeping the pole star towards the left. If you are going towards this direction, pole star is towards your left. Simple answer है. Direction keeping the pole star to your left. You walk in the direction facing the pole star, you will go north. You walk in a direction opposite to pole star, you will go south. You walk in the direction keeping pole star to the right. If you keep pole star to the right, you are actually going away from your village. Keep the pole star to your left and walk towards your village. For 5 kilometers, you will reach your village. Simple answer. So I hope many of you are able to catch this. Okay, so I have a doubt. I feel the class is going bit slow. If you ask me, it is going very slow. So how many of you feel that I can increase the pace of the class? थोड़ा सा speed बढ़ा सकता हूँ, please बताइए. Should I increase the pace of the class? Yes. Or should I continue in the same pace? Or should I decrease the pace of the class? Okay, I'm talking about the speed of the class. Okay, because I had planned to finish all this thing in the yesterday itself and आधा class हो गया and we are still here. Fine. Because I keep seeing the doubts, many of the doubts coming up. So I have the doubt whether you are really able to catch up this or not. Please give your answers. Should I increase the speed of the class? Or should I continue in the same speed? Or if you think I should decrease, give your answers please. Because ये जो इंट्रोडक्टरी चैप्टर है ना, इससे ज़्यादा क्वेश्चंस नहीं आता. इट्स वेरी बेसिक थिंग एंड यू डोंट हैव टू नो इन वेरी डिटेल. दिस इज द एग्जांपल ऑफ द क्वेश्चन विच यूपीएससी इज आस्किंग. तो डिटेल पढ़ के फायदा नहीं है इसमें. सो कंसिडरिंग दैट यू गिव मी योर आंसर्स एंड बेस्ड ऑन द ओवरऑल आइडिया आई विल टेक द कॉल. Okay, Anjuman is saying yes, please increase the pace. Anyone? और कोई? Tushar is saying pace is right, however you can increase a little bit but please decrease the speed of giving notes. अच्छा notes ज़्यादा fast हो रहा है क्या? यार notes तो आपको adjust करना पड़ेगा because you have to practice writing faster. ठीक है, I'll decrease for now but with time I'll increase because it is very important that you have to write faster. So Sushant is saying you can cut the recap of the class and also little less detailing of unimportant topics. ये तो you guys would decide depending on the query. I would think of repeating जितना repeat करना है because I would have seen the previous classes query, so I would try to give that. ठीक है, I'll try to make it bit lesser about the recap. Fine. Okay, Rohit is saying that because I am reading the comments so that others would also understand what others are feeling. Okay, so Rohit is saying that for first timers like him, it's going in a very understandable manner. Please stay in the same form. Okay, so Meenakshi is saying increase a bit, keeping the basics as many of us could be from non-geo background. Okay, so I would say 50-50 hai abhi tak. Anything else? Few of them want to go in the same speed and few of them wants to increase. Kavadi is saying that please increase the speed. Jagjit is saying please increase the speed. Ishan is also saying increase the speed. Okay. Anything else? Manisha is also saying speed can be increased. Okay, so considering all these things, I would say nearly 70% of the students are saying we can increase, but 30% are saying that we should continue. So I'll make a compromise here. Okay, of course I'll not make a compromise with the quality of the class. So जो factual चीजें हैं वहाँ पर I won't give the notes. Fine. The factual चीजें जो भी है like आगे जो आएगा information related. So I'll tell here you take the running notes. Take the running notes. There I don't have to explain also much. In few of the concepts related I'll explain in detail, I'll slow it down and I'll increase the speed in those topics where it is bit factual and informative type. And I'll tell you beforehand this topic, what is the relevance of this topic from UPSC. If it is very important and previous UPSC question आया है, I'll slow it down with enough slow speed so that you will understand. And in those topics if I'm speeding it up, so you have to understand that this is not that important, इतना detail में जाने का ज़रूरी नहीं है. Okay, so I'm going to increase a bit. I'm going to increase the speed of the class a bit, and I'm not going to compromise in terms of the conceptual understanding. That one guaranteed. At if any point of the time you feel that it is going too fast, or if you think that some more, once more or twice more, if you want me to explain, you please let me know, I'll explain. Yeah, let's do this. Okay, next topic, solar system. Solar system, this topic is going to be bit more informative type. Okay, few concepts are there, I'll explain that concept. So other than that, it's most of it is informative type. So what is solar system? Solar system to pata hai, it's our planetary system. We have sun, which is our star, surrounded by 8 different planets. पहले 9 different planets were there. When I was in school, I read it as 9 planets. When I came to college, तो 8 हो गया, है ना, एक गायब हो गया. I'll tell you the reason behind that. I hope most of you would have read in your school as 8 planets only. We have the sun and the 8 planets and their satellites, and in between we have different bodies. All of them together, it is solar system. है ना? So it's basically our solar system. And what is the age of solar system? 4.8 billion years. and 13.7 billion years is the age of universe. है ना, solar system originated before the 4.8 billion years from now. यहाँ से 4.8 billion years पीछे जाओ, or you can also written it as 4,800 million years. In many of the sources you might have read like this. So this is basically the age of our solar system. It was formed recently. Compared to many other systems in the universe, this is one of the very recent one. So how did it form? What is the process which led to the origin of our solar system? Universe का origin तो मैंने बता दिया. If at all, you have to very carefully read the question, whether the question is about the origin of universe or origin of solar system or origin of earth, origin and evolution of earth. You have to explain in a different manner. I have already told you the origin of universe. So there are three different theories: steady state theory, pulsating theory, Big Bang theory. Most widely accepted Big Bang theory. Universe तो हो गया. It led to the evolution of all the different elements, gases and all. And I also told you how the stars would evolve, how the solar system evolved, how the different planets evolved, how we became one single system. That is what is origin of solar system. To explain the origin of solar system, we have two different types of theories. One is evolutionary theory and second one is catastrophic theory. What is evolutionary theory? Okay, this theory is almost similar to the evolution of life on earth. Many of the people think that life evolved on the earth. That means gradual, जो हमारा डार्विन का theory है, which says from one species to another species evolved gradually by adjusting. So that is what is evolutionary theory. Many of the people also believe that life evolved on the earth as an accident. कुछ accident होके suddenly evolve हो गया. That is what is catastrophic theory. In the same way, these people also say that the planets and the sun of जो भी everything of solar system originated in a gradual evolutionary manner. That is what is evolutionary theory. And few of the people say that no, it is because of some kind of accident, some single event, accidentally some catastrophic event happened, and that is what is catastrophic theory. There are two theories in case of evolutionary and two theories in case of catastrophic. There are many theories, of course I have taken only the important ones. The first evolutionary theory is the theory of gaseous hypothesis by Immanuel Kant. Okay, we know about Immanuel Kant, the great philosopher, German. And another important theory is Laplace hypothesis, nebular hypothesis of Laplace. These are the two important evolutionary theories: gaseous hypothesis of Immanuel Kant, nebular hypothesis of Laplace. So what exactly evolutionary theories? Both the theories say something common. So basically evolutionary theory says that the entire solar system evolved together. That is, along with the evolution of the sun, all the different planets also evolved. That is, they evolved from the same gaseous cloud. There was one huge gaseous cloud, in that the center part became the sun and the surrounding part became the planets. That is what is evolutionary theory. So what makes the evolutionary theory different from catastrophic theory? Catastrophic theory says that the sun was already existing. There was one sun and there was no planets at all, and because of some catastrophic events, some of the material came out from the sun and that formed the planets. Okay, here also it says the material is coming from the sun only, but sun was existing pehle. Sun was already existing, then the material came out of the sun and those material got separated and it became planets. So as per the catastrophic theory, you can see that the planets are younger than the sun because they have formed later. As per the evolutionary theory, planets are of same age as that of sun. So what is this gaseous hypothesis? Gaseous hypothesis of Immanuel Kant was one of the earliest hypotheses which talks about the evolution of solar system. Few of the basic things what the gaseous hypothesis says. The gaseous hypothesis says that there was some kind of supernaturally created hard particles how they were created supernaturally matlab we don't know how they originated. There were some supernaturally created hard particles which were very, very cold, and these hard particles started to collide with each other. Why would they collide? They started to collide with each other because of the gravitational pull. We know about the gravity. Wherever there's two different mass, it pulls towards each other and it starts to collide. Okay, in the same way they started to collide with each other. And this collision, because of the collision, it released heat, and during this process it started to rotate. The entire gaseous body started to rotate. Pura aise it started to rotate. So what are the things? It said that there was this supernaturally created cold and hard particles. They started to collide with each other because of the gravity, and that released heat, and during that process it started to rotate. And once it started to rotate, from this the rings of matter started to eject. Because of what? Because of centrifugal force. Any rotating body is there, it started to eject the rings of matter, and from this the rings of matter started to get ejected, and these rings of matter became concised, became concrete, and that became planets. And this is at the center, it became the sun. This is what is gaseous hypothesis. Gaseous Q, it originated from a gaseous cloud. So there was this gaseous cloud made up of cold and hard particles which are supernaturally created. They started to collide with each other, and that released heat, and because during that process it started to rotate, and during the rotation the rings of matter got ejected, and these rings of matter got concised, it got concrete and became planet over the period of time. क्योंकि इससे बाहर आते 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 टेम्परेचर थोड़ा कम हो गया, so this temperature reduced and it became planet. This is what is gaseous hypothesis. Of course there are many issues with this. ये supernaturally क्या है? We don't know about this. He did not tell how this originated. ये rotation कैसे हो गया? You told me that there is this heat. How the rotation came up? Because it would require some kind of the spinning force. He did not give any kind of mechanism for this. Basically this theory is very minimal. It was in 18th century, okay, 1750 के आसपास. That was the time of Immanuel Kant. So that time he gave in a very primitive manner. So this is what is gaseous hypothesis. So then came the Laplace. He is almost 50 years ahead of Immanuel Kant. He gave minor modification. He almost gave the same theory, but few other things he said. What are the things said by nebular hypothesis of Laplace? Nebular hypothesis says that there is this already rotating nebula. He did not go into too detail about how it was formed. He says that there was already rotating nebula. What is nebula? Cloud of gas. And that cloud of gas was already existing in a rotating manner. Okay, it was pre-existing in a rotating manner. And as it started to rotate, gradually it started to cool down. क्योंकि रोटेट होते होते it started to expand and it started to cool down, and when it started to cool down, because the temperature has started to reduce, it started to form condensation. थोड़ा सा concrete होके it became concise, it became more concise. And gradually, because of the reduction in the size, this entire cloud of gas became compact, it became a disc shape. है ना, जैसे मैंने दिखाया था मिल्की वे गैलेक्सी, how it is disc shape. This entire cloud of gas became disc shape, and from that disc shape, since now the mass has increased, the density has increased, the spinning has become more, the spinning speed has become more, and during that again the rings of matter got ejected, and these rings of matter cooled down to form different planets. At the center again we have sun. Metas, what is the difference? ज़्यादा difference नहीं है. Okay, basically Laplace talks more about the condensation, more about the spinning effect. He says temperature कम हुआ था, उसके वजह से the density would have increased, that would have led to increase in the speed of the body, and that would have made the entire gaseous cloud a flat disk, and disk से तो rings of matter coming out would be easier. Gaseous hypothesis, nebular hypothesis. And nebular hypothesis is one of the widely accepted. Okay, even though there are further developments which has happened here, but this is said that nebular theory is widely accepted. And this is how even our Big Bang theory also would be supported. Because gaseous cloud hoga, gaseous cloud say the stars would be formed and all. So this would be almost widely accepted, you can say universally accepted. Mechanism, you don't have to go into detail about the mechanism. Catastrophic theory. What is catastrophic theory? The sun was already existing, catastrophic event happened, and because of that the matter from the sun, inside the sun got ejected. That is what is catastrophic theory. There are two catastrophic theory, planetesimal theory as well as tidal hypothesis. इसमें ज़्यादा details नहीं है. Planetesimal theory was given by Chamberlin and Moulton. Tidal hypothesis was given by Jeans and Jeffries. In both the cases there was sun already existing. There was sun. And in both the cases it assumes that along with sun nearby there was another star. In case of planetesimal theory, it says we have the sun which was called as protostar, the star which was existing, and along with the sun there was another star which is very near to the sun, both paas mein tha, that was called as companion star, which was the companion of our sun. There was protostar and companion star, and by accidentally this companion star came very close to the sun, both paas mein aa gaya rotate hote hote, because all the stars rotate around that black hole in the galaxy. Rotate hote hote this star came very near to the sun. Two heavy bodies came together, came towards each other, and because of that the gravitational pull is increased, and because of the presence of this companion star the mass from inside the sun got ejected, and this mass which got ejected from the sun started to revolve around the sun in different orbits, because the star was moving in this direction. उसके वजह से it started to revolve around the sun in different orbits, and this mass gradually condensed, gradually became more concrete, and that led to the formation of different planets. जो initial छोटा छोटा bodies which were there before it became huge planet, and those small bodies are called as planetesimal. Planetesimal is also called as, you can say, protoplanet. There were this very minute small bodies. Over the period of time they merged together, they got accreted together and formed a huge planet. This is what is planetesimal theory. Tidal hypothesis is almost same, but he uses the word sun and intruding star. This was intruding star. Okay, suddenly one of the star intruded and it came very near to the sun, and because of this gravitational pull, a huge tide of mass came out. He uses the term tide. Tide is huge wave of mass came out like this, and gradually it started to revolve around the sun like this. And over the period of time this got accreted and it became planets, and all of them are rotating in this direction only. So these are the theories of origin of solar system. Earlier we had seen the origin of universe. In case of planetesimal, there was this protostar and companion star. Since the protostar came near to the sun, the matter got ejected and this started to revolve around the sun, and this matter, this pre-matter, the pre-planet matter was called as the planetesimal. All the different planetesimal got accreted together and it formed a planet in different belts. We use the different terminologies in tidal hypothesis. It said the tide of matter came out because of an intruding star which was very massive. Okay, Tushar, you are asking to repeat the catastrophic theory. I am telling again. Intrusive star, intruding star, which was very massive. Because of the gravitational pull, the matter got ejected as a huge tide, and this material got accreted in different orbits around the sun. That is what is tidal theory. Tidal theory basically says that huge matter, huge tides came out of the sun. The tide of material came out of the sun. You just have to remember mechanism same hai, dono ka mechanism same hai. You just have to use the terminologies. Here what is the terminology? Protostar, companion star and protoplanets, which are called as planetesimal. Jeans and Jeffreys don't use this. He uses the term our sun and the massive intruding star, because of which the tides of matter came out, which led to the formation of protoplanets, and they got accreted together and they formed different planets in different orbits. Okay, you write this down. After that, if you have any doubts, you tell me. Okay, since the catastrophic theories uses the presence of two stars, they say there were two stars earlier existing, so that's why catastrophic theories are also called as binary theory. They are also called as binary theory. Binary means presence of two stars. Fine? You can write evolutionary theory. Okay, heading evolutionary theory. The material of solar system condensed into sun and other planets simultaneously from a single mass of from a single mass of gaseous cloud. Gaseous cloud. Therefore, both the sun and other planets, both the sun and other planets are of same age, are of same age. Okay, in that the first one, gaseous hypothesis. Gaseous hypothesis by Kant, K and Kant. As per the theory, there was an existence of supernaturally created cold and hard particles, cold and hard particles which collided with each other due to gravitational attraction, full stop. The collision released heat and gradually formed a rotating nebula kind of structure, from which the rings of matter were thrown off, full stop. This cooled down, this matlab the rings of matter cooled down to form different planets. And basically there was this huge cloud, the gaseous cloud, which is made up of the supernaturally created hard particles. These hard particles started to collide with each other and that released heat and it started to revolve, the body started to spin, and because of the centripetal force the rings of matter got ejected. And these rings of matter, जो surrounding में जो rings of matter था, पूरा ring बना हुआ था, and over the period of time it got concrete, मतलब accrete होके it became planets. Next one, nebular hypothesis. Nebular hypothesis of Laplace. It assumes a pre-existing nebula, in a rotating state, pre-existing nebula in a rotating state. Full stop. With gradual cooling, the nebula shrank, This led to more spinning, and formation of a flat disk This led to more spinning and formation of a flat disk. Full stop. Rings of matter got separated. Rings of matter got separated from this disk and condensed to form planets. Condensed to form planets. है ना, almost same, but यहाँ पर he specifically uses the term nebula and he describes the term nebula. कैसे flat disk हो गया and because of the centripetal force इसके material came out. है ना, some more specificity he has added and he talks about nebula. Nebula was existing. वो कैसे origin हुआ था वो मुझे पता नहीं. Okay, there was already nebula. That is how even the stars would originate. Okay, from a nebula. Yesterday we spoke about the origin of stars. Second, catastrophic theory or binary theory. Catastrophic theory or binary theory. In that the first one, planetesimal hypothesis. By Chamberlin and Moulton. Chamberlin and Moulton, M-O-U-L-T-O-N, Moulton. Chamberlin and Moulton. As per the theory, the protostar is accompanied by a companion star, full stop. As the companion star came near the protostar, its gravitational pull led to the ejection of matter from the protostar. Which gradually evolved into planets. The material existed before the evolution of planets are called as planetesimal. Next, tidal theory by Jeans and Jeffreys. Jeans and Jeffrey, J-E-F-F-R-E-Y, Jeffreys. Okay, Jeans and Jeffreys. It proposes a very big intruding star, which came near to the sun, the gravitational pull led to the ejection of tides of material, which formed the planets. है ना, simple है. So we had this huge intruding star, it came very near to the sun and this pulled the material, क्योंकि gravitational pull हो गया, like a huge mass has come near to the body of the sun and सन इज वेरी यंग, तो इसके अंदर से द yeah. So I hope the tidal theory is clear. I explain it again. So Arvind is asking, out of all this theory, which one is more relevant? I told you our nebular hypothesis is more relevant and it is widely accepted. Fine. So if at all the question comes on explain the different theories related to the origin of solar system, you should begin with Big Bang, because Big Bang is the theory which explains the origin of universe. Begin with Big Bang, explain one paragraph about Big Bang, then you come to the solar system. Solar system may start with the gaseous hypothesis of Kant briefly, then you explain nebular hypothesis, then briefly about this planetesimal and tidal. इतना काफी है. And you should not go into too detail जाने का जरूरी नहीं है. It is not going to be helpful if you explain it in very detailed manner. That is not at all required. Very brief, जितना मैंने notes दिया उतना काफी है. Fine. So most widely accepted for origin of universe ये तो पता है Big Bang, and in case of origin of solar system it is nebular hypothesis. Now, so in solar system the most important one is we have the sun. And the sun, which is our star, we call it as sun. And so do you know that 99.8% of the mass of solar system is in sun only. Whatever is there, everything, it is just 0.2%. All the different planets. Okay, so that gives you an idea how big the sun is, and with comparison to the sun, how all the other different planets. And that too, I told you 8 planets are there. What are the 8 planets? Mercury, Venus, Mars, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So this gives the comparative size of all the different planets. You can see in all the different planets how big the Jupiter is. Kitna bada hai? And all the other planets are there, very very big. Is that right? And can you see the size of sun in comparison to all this? We cannot put the sun in this. That's why we have just given a small curvature. It appears almost like a straight line. Can you imagine this curvature forming a huge circle? So that is what is sun, which comprises of 99.8% of entire solar system, entire mass of solar system. And its age is 4.8 billion years. It has 7 billion years more. Okay, अभी से आगे 7 billion years तक it has a life. After that it will become a red giant, and red giant will become a planetary nebula, and then it will become a white dwarf and black dwarf. That is how it is going to be. It still has 91% of its hydrogen. It is still there. It is one of the young stars. So you don't have to worry. बहुत आगे है. तब तक तो हम रहेंगे भी नहीं. Now that is for sure. I am talking about the human species. So let's talk about the sun. Sun, we have to see very briefly the important aspects of sun. So one is different layers of the sun. Okay, जैसे earth is also made up of different layers, the sun is also made up of different layers. The interior layers and the atmospheric layers. Total there are 6 layers. 6 layers in the sun. There are 3 layers in the interior. Okay, if you imagine sun as a huge ball, तो अंदर 3 लेयर है एंड उसके बाहर 3 लेयर. बाहर में क्या होगा? Like it's majorly the atmosphere. The sun's atmosphere is made up of 3 layers and the sun's interior is made up of 3 layers. The most inner one is core. Above the core we have radiative zone. Above the radiative zone we have convective zone. These are the 3 interior layers: core, radiative zone, convective zone. Interior हो गया. Atmosphere is also made up of 3 layers. The lower most layer is photosphere. Photosphere. Above the photosphere we have chromosphere. Above the chromosphere we have corona. Core, radiative zone, convective zone, photosphere, chromosphere, corona. Of course, corona is very new term for the world, and for geographers this is a very old term. So कैसे दिखेगा? If you take the cross section of, if this is what is the sun and you take the cross section of this center से, so we have core, radiative zone, convective zone. So above the convective zone the atmosphere, lowermost one is photosphere, chromosphere and finally corona. 6 layers. ये आ गया है. So which is the lowermost one? Core. If you remember, I told you during the origin of the life cycle of a star, core is the part where the nuclear fusion reaction would happen. For any star, the nuclear fusion reaction would happen at the core because that is where the temperature is highest. And what is the temperature required for the nuclear fusion reaction? 15 million degrees Celsius. It should be 15 million degrees Celsius. The sun's core is also of this much of temperature, that is 15 million degrees Celsius, and that is where the fusion reaction is happening, where the hydrogen is leading to the formation of helium plus energy, and that energy is released. This is the hotter most, that is in terms of temperature, this is the hottest region of the sun. And the second one is radiative zone. Why we call it as radiative zone? Because the heat from the core comes out as radiations in this. It comes out as radiations. The heat is transported to the upper layers as radiations of heat. That's why we call it as radiative zone. And the third one is convective zone. Convective zone is where the heat is transported to the much higher layer through the process of convection. What is convection? So along with the gaseous mass itself, it is moving. As a huge gaseous mass, it moves up. The heat is transported as a gaseous mass itself, along with the gases itself. So that is what is convection. If the heat is transferring as a radiation itself, as a electromagnetic radiation itself, the radiation of heat itself, that is what is radiation. In this zone it goes as a radiation, here it is convection. Through convection the heat is transported to the upper layers. Above that we have photosphere. Why it is called as photo? फोटो क्यों है? बिकॉज इट इज द ब्राइटेस्ट, it is the brightest layer of the atmosphere. Okay, these are the three layers of the sun's atmosphere, and this is the brightest, and this is the layer from where the visible light is originated. Okay, among all the different spectrum, electromagnetic spectrum, only some part of the light is visible for our human eyes, naked eyes, and that is what we call it as visible light. So visible light originates from this photosphere. That is why the photosphere is the brightest layer. And the thickness of this photosphere is 300 kilometers. It is the brightest and it is the lowermost layer of the atmosphere, and this is the layer from where the visible light originates. Photosphere. Above the photosphere we have chromosphere. What is the meaning of chromo? Chromo means color. It is bit reddish in color, but in a normal sun, if you observe the normal sun, we don't see any other layer. What we see is just photosphere, because it is that bright. Photosphere is so bright for the human eyes, we won't be able to see the other layers. The light coming from the photosphere is that bright, we just see the photosphere actually, if at all we are seeing. So in normal conditions, the chromosphere as well as corona is not visible. So what is corona? Corona is the topmost layer, and it comes like a crown. That is why it is called as corona. ये हमारा virus भी इसीलिए तो it's named after that. It is the topmost layer, it is the outermost layer, mainly made up of very hot gas, and very mysteriously the temperature from photosphere to corona rises. I told you what is the temperature at the core, 15 million degrees Celsius. So that temperature at the photosphere is just 5500 degrees Celsius at the photosphere, but at corona it is nearly 2 million. This is very mysterious. अभी तक पता नहीं है why the temperature in corona is rising. Nobody knows. We are yet to discover. So basically corona is the hottest layer of the sun's atmosphere. Core, radiative zone, convective zone, photosphere, chromosphere, corona. And what we see in the sun is usually photosphere, what is visible. But during a total solar eclipse, what is total solar eclipse? When the sun is completely blocked by the moon. Moon comes so that we will not be able to see the entire sun completely. Pura block ho gaya. That is what is total solar eclipse. In that case, when this entire surface of the sun is covered, we can see this hot gas surrounding this. That is what is corona. So basically the topmost layer is visible only during the total solar eclipse. During the total solar eclipse, the entire photosphere is completely blocked. The bright layer is completely invisible. So isliye this layer is visible. Corona as well as the edge of the chromosphere. Can you see these red spots? The red border of this line. So that is what is chromosphere. Chromosphere is also visible. Corona is also visible during the total solar eclipse, and it is only during the total solar eclipse. Okay, you can write briefly about this, brief points. Layers of sun's interior. First one, core. It is the innermost layer. Innermost layer with highest temperature. With highest temperature up to 15 million degrees Celsius. Nuclear fusion reaction happens here. Next one, radiative zone. Energy from the core. Energy from the core is carried outward. By radiation through this zone. It's carried outward by radiation through this zone. Third one, convective zone. It is a zone of convective currents. It is a zone of convective currents where the photons through convection reaches the surface. Fourth one, photosphere. Photosphere, it is the lowest layer of sun's atmosphere. Lowest layer of sun's atmosphere. Next point, it is the brightest layer and visible light originates from this layer. Visible light originates from this layer. The temperature is 5500 degrees Celsius. Fifth one, chromosphere. It is the intermediate zone which appears as a red rim, during eclipse. Sixth one, corona. It is the uppermost layer of atmosphere, sun's atmosphere. And is visible only during the total solar eclipse. It is hotter than photosphere with temperature reaching up to 2 million degrees Celsius. So we have two queries, both are almost same. Vedant is asking how do we know there are three layers, inner layers, and Biprajit is also asking the layers of sun are theories or we have proof. We have sent many exploration probes near to the sun and we can also see the sun because sun is one of the very brightest and also बहुत बड़ा है. It's not like what we see from the naked eye. We have used various different telescopes to analyze the sun in various different range of radiations. है ना, तो अल्ट्रावायलेट, IR, बहुत ज़्यादा डिफरेंट कैमरास यूज़ करके हमने ये सारा एनालाइज किया है. सो दिस इज एक्सप्लोर्ड पार्ट. वी हैव सेंट मेनी प्रोब्स आल्सो नियर टू द सन. द सन इज अ वेरी huge body here, like compared to any other planets, we can clearly see that. So we have few terms related to sun. One is solar flare. What is a solar flare? Sometimes from the sun suddenly hot gases, hot elements are burst into the space. है ना, if you see the surface of sun, it is not completely uniform, ऐसे ऐसे होता है. This sudden burst of hot gases, hot atoms is called as solar flare. Because obvious reason है कि like the magnetic field might be varying. There would be too much of magnetic activities, or even the nuclear fusion reactions might also vary from one region to another. So temperatures, pressure condition, ये सारा मिला के the effect is that there is sudden outburst of these hot gases, hot atoms into the space. We call it as solar flare. Okay, so you can write what is solar flare. The sudden burst of storm of hot atoms released into the space are called as solar flares. Okay, then what is sunspot then? You have heard the term sunspot. Sun is very bright, है ना? You observe through the various instruments, the telescopes, various instruments which we have developed to watch the sun. You can observe that on the surface of the sun there would be certain dark spots that is visible on the photosphere. The black spots, that is what is called a sunspot. They are dark spots. Why they are dark spots? Because the temperature is lower in these regions. Temperature has dropped bit in comparison to the other surrounding region. So there the energy radiation released is bit less. The temperature has dropped, but the magnetic activity has increased. Magnetic activity has increased. There is huge magnetic force is acting over there. The magnetic field is stronger over there. So that strong magnetic field will not let the sun's radiations to go too much into the space. It will control, it will act as a bit controlling force on this sun's radiation. इसलिए थोड़ा सा temperature कम होता है वहाँ पर. Okay, always remember dark spots. These are the dark spots, the sunspots are the dark spots on the surface of sun with lesser temperature and higher magnetic field, higher magnetic activity. The higher magnetic activity reduces the temperature over there. Okay, it acts as a kind of inhibitor. That is sunspot. These sunspots are not fixed. ऐसा नहीं है कि एक ही जगह में sunspot मिलता है. You can find sunspots all across the surface and they can also disappear. For sometimes it will be there and sometimes it will not be there because it entirely depends upon the reactions which are happening in the interior. So the number of sunspots on the surface of sun keeps varying from one year to another year, one period to another period. And the numbers also increase. Sometimes the sun is full of sunspots, pura dark, to such an extent that it has highest number of sunspots. Sometimes there are no sunspots at all, pura bright. I'm talking dark bright, तो light which is reaching the surface of the earth उससे फर्क नहीं पड़ता है. But if you see the sun, you will see some dark spots. बस और कुछ difference नहीं है for earth. But this is not something random. The number of sunspots on the sun's surface would start to increase, it reaches the maximum position and then it would start to decrease. It goes in a cycle. If you see, this is the sunspot, number of sunspots. Sometimes it will reach a very high number, sometimes it will come down, sometimes it will reach a very high, sometimes it comes down. And the period between the one lower to another lower or one peak to another peak for one complete cycle, you would say. So that is actually 11 years. So in 11 years, it will change from one maxima to another maxima and it will see a one minima. So between one maxima to one minima, this is 4 to 5 years. Between one minima to another maxima, this is again 4 to 5 years. So in total, between one complete cycle, there are 11 years. So that is what we call it as solar cycle. So in a solar cycle, we will have one solar maxima, one solar minima. Solar maxima is highest number of sunspots, solar minima is lowest number of sunspots. Okay, this is solar maxima. This is solar minima. Solar maxima was in 2014 and solar minima was in 2019 and 20. Recently there were few news articles saying that sun has entered its solar minima. Okay, we are in solar minima. That means the sunspots which are visible on the surface are very, very less. So is there any effect? कुछ effect रहेगा इससे? Very few effects. I told you, when there are sunspots, in those regions the temperature is bit lesser and magnetic activity is higher. When there is magnetic activity, it will not let the explosions too much. जो solar flares होता है, sudden burst of hot gases into the air, that would be bit lesser. थोड़ा सा control में रखता है चीजों को. When there is solar minima, the dark spots are less. There are chances that higher storms of atoms might be released into the space. And that might affect astronauts who are in the space. Because we have a huge atmosphere and atmosphere also has a magnetic field surrounding Earth. है ना, that will protect us. हमारे लिए ज़्यादा issue नहीं है, but maybe the astronauts in the space, they should be bit careful. ऐसा भी नहीं है कि suddenly ज़्यादा हो गया है. Okay, they should be bit careful. And second thing, it is also said to disturb the communication satellites, जो हमारा communication link है, which works on the Earth's atmosphere. There are chances that it might be disturbed. Okay, these are the possible effects of the solar minima. Okay, you can write what are sunspots. These are the dark portions on photosphere with reduced temperatures. But strong magnetic activity. The number of sunspots on the surface increases or decreases increases or decreases over a regular period of 11 years. It is called as solar cycle or sunspot cycle. Solar cycle or sunspot cycle. Full stop. Solar maxima is the time when high number of sunspots are visible, and solar minima is when there are least number of sunspots. Impacts of solar minima, you can write solar maximum was in 2014 and solar minima is in 2019-20. Currently we are in solar minima. So impacts of solar minima, possible impacts of solar minima. The decreased magnetic activity might increase the solar storms into the space and it might affect the astronauts in the space. Second, it might also affect the communication links on the surface of Earth with minor disturbance. क्योंकि communication links, everything works on the magnetic field, the radiations and all, वो सब हम climatology में पढ़ेंगे, ionosphere है, so that might be disturbed because of increased solar activity. So solar flares. So we have a query by Ritika. Sir, you said corona is the hottest layer but core should be the hottest. Yes, I was talking about the corona as the hottest layer of atmosphere, not the entire layer. I told you 3 layers in the interior, that is core, radiative, convective. These are the interior layers. Surface के नीचे है, surface के ऊपर we have photosphere, chromosphere, corona. In these 3, corona is the hottest. Okay, it is the hottest layer of sun's atmosphere. Okay, this is how the solar maxima, solar minima would appear. Solar maximum with highest number of dark spots, sunspots. Solar minima is the lowest number of sunspots. So now I'll give you brief data about all the other planets. You keep writing, इसमें कुछ explain करने का जरूरी नहीं है. Fine. So this gives you the comparison. Of course, the distance is not this close. इतना close तो नहीं हो सकता है. Distance हमने reduce कर दिया. How the planets would look like in the presence of sun. These are very small planets. The first 4. What are they? Mercury, Venus, Mars, Earth, Mars. Then we have Jupiter, Saturn, Uranus, Neptune. We have a division of 2 different groups of planets. The first group of planets are also called as terrestrial planets. The next group of planets, you can see they are very huge in size. They are called as Jovian planets. What are the difference between terrestrial planets and Jovian planets? You can see the name terrestrial planets means Earth-like. Jovian means Jupiter-like. Earth-like, Jupiter-like. That is what is the name terrestrial and Jovian. So what is the major difference you can see? These are rocky Rocky planets, these are gaseous planets. They are also called as gas giants. That is majorly made up of gaseous elements. These are very hard and rocky. And obviously these are very, very small, these are huge in size. Q, because you can see the nebular theory. There was this huge cloud, center में तो sun बन गया, and बाकी सारा all the material got distributed. है ना? And only the lighter elements were able to reach the farther distance. Heavier elements, they were near to the sun, gravitational pull. And also second, the sun's rays, the solar flares which comes out of this, the solar wind which would say, that will take away all the gaseous elements. This will push the gaseous elements into the further outward, but the heavier elements will be retained here because of solar wind. Solar wind will strip these gaseous elements into the outer layer. इसलिए सारा gaseous elements बाहर चला गया, and they have formed huge planets over there, and we have rocky planets here. These are rocky and hard, these are gaseous, these are very small, these are huge planets, huge in size, which would experience strong solar winds. This would experience weak solar winds. Okay, this would experience strong solar winds and this would experience weak solar winds. Okay, I hope you are writing this. And because of the strong solar wind and weak solar wind, it also has another effect. The atmosphere of these planets are very thin. It has very thin atmosphere. Why? The gaseous elements will be washed away very easily by the solar wind. Solar winds are so strong. Solar wind मतलब sun से जो winds आता है. But the gaseous giants, they have very thick atmosphere. Because they are able to hold on to these gaseous elements, वहाँ पर solar winds का effect कम है. So this is thick atmosphere. The number of satellites are less. Here it is more. What is the reason here? The bodies itself, they are small and they will have very few satellites. These are very huge bodies. They can have large number of satellites. Their gravitational force is very high. They can attract many bodies. यहाँ पर तो नहीं होगा. That is why the terrestrial planets will have lesser satellites and Jovian planets will have more number of satellites. Terrestrial planets are warmer in temperature. They are colder in temperature क्योंकि sun से तो बहुत दूर है. Since they are located in a position far away from the sun, they are colder in temperature. The terrestrial planets do not have any kind of rings. The gaseous planets have rings. In that, the most visible one is Saturn's rings. But all the gaseous planets have the rings. It's not only on the Saturn. Their rotation speed is slower. The rotation speed of terrestrial planets are bit lower and rotation speed of Jovian planets are bit higher. Why? Because they are majorly gaseous elements. To hold on to this gas, they have to rotate fast. तब भी they will be able to hold on to the gaseous elements. Now let me tell you a few interesting things about these planets. Starting one by one. Mercury. You can see Mercury is the first planet from the sun. And this is also the smallest planet. You can keep writing this information. Mercury is also the smallest planet of all the 8 planets. This is the smallest. And it has no atmosphere at all. मर्क्यूरी का कोई भी एटमॉस्फेयर नहीं है. वाई? बिकॉज इट इज सो नियरली रोकेटेड, है ना, सन का इतना सा पास में है. द सोलर विंड्स वुड बी सो स्ट्रांग, इट वुड नॉट हैव एनी काइंड ऑफ गैसियस एनवायरनमेंट सराउंडिंग दिस. एवरीथिंग विल बी कंप्लीटली स्ट्रिप्ड ऑफ. That is Mercury. It is the smallest. It has no atmosphere. Second one is Venus. Venus is called as Earth's twin. Now, why Venus is called as Earth's twin? Because its size and mass is almost same as that of Earth. You can see almost same here, Earth and Venus. But there is no possibility of life on Venus, because Venus is the hottest planet in the entire solar system. It's not even Mercury, it is the Venus which is hottest. Can you guess any reason? What should be the reason here? Why the planet would become hot? Why we are talking about the global warming? Because of greenhouse effect. So what is causing greenhouse effect? Carbon dioxide. Venus has 95% of carbon dioxide in its atmosphere. The greenhouse effect is very, very high over there, because of which there is no possibility of life at all. Okay, remember this is called as Earth's twin. Venus is called as Earth's twin, and this is also the brightest object in the sky. It is very easy to identify. Of course, this will not twinkle. All the planets would not twinkle. It appears like a star, क्योंकि हमारे for the human eye it is difficult to see, but it will not twinkle. And what about Earth? Earth was also called as blue planet. ना blue color, दूर से तो blue color दिखता है because of ocean water, of course. And Earth is the densest of all the planets. The density of Earth as a whole planet is the highest. Of course, gaseous giants का तो density बहुत कम रहेगा. Among all the terrestrial, still Earth is the highest. That's why Earth is the densest of all the planets. It is mainly 35% it is made up of iron only. More than 35% it is iron only. It is the densest. Next, Mars. Mars is bit smaller than Earth. थोड़ा सा it's smaller than Earth, and it appears red. That's why it is called as red planet. Okay, Mars appears red, and it's called as red planet. Even in the sky also थोड़ा सा dim दिखता है. It appears bit dim, reddish. If you have a telescope, you can clearly see that. But among all the different planets, Mars is the only probable planet with the probable conditions suitable for the existence of life. Possibility है वहां पर, क्योंकि temperature is not that extreme. Okay, जितना moderate temperature है, that is there. That's why we have been sending the probes into that, and even our Elon Musk, who has the idea of colonizing Mars, है ना, he thinks that the Earth is doomed. ये तो save नहीं कर सकते. We have to think of the alternatives. So you can read about that. So after Mars, we have Jupiter. Jupiter is the largest planet of solar system. You can see the size comparison itself. It is the largest. कितना बड़ा होगा? It is 11 times the size of Earth. It is 11 times the size of Earth. The most striking feature on the Jupiter, can you see? The most striking feature on the Jupiter, it is the red spot on the Jupiter, the huge red spot. Okay, this huge red spot, it is one of the very striking features of Jupiter. It is so huge, it is twice the size of Earth itself. What is that red spot? So it's basically a huge spinning storm which keeps moving on the surface of Jupiter. Huge spinning storm. You can imagine Earth का double size है. This appeared 400 years ago. 400 years से ऐसे it's still visible. That is the red spot of Jupiter. Next one, Saturn. The most striking feature, you can see the rings of Saturn. And another important thing is that it is the lightest planet in the entire in the entire solar system. It is that light that it is lighter than water. पानी से भी उसका density कम है. That means if you put Saturn in a bowl of water, so it will actually float. ना इतना बड़ा planet तो है, you can imagine how much of water it would require. It is Saturn. It is the lightest of all. After Saturn we have Uranus. Uranus has a very peculiar feature among all the different planets of the universe. Okay, this picture shows the difference between Jupiter and the Jovian planets and terrestrial planets. Jovian planets are basically, it's not completely gas. Some metallic elements are there, but it would majorly consisted of gaseous elements, lighter elements बहुत ज़्यादा होते हैं. Okay, at the core there would be rock. The most interesting feature of Uranus, its tilt in the axis. मैंने बताया अभी था. Earth is tilted by how much of degree? From vertical it is tilted by 23.5 degrees. Uranus is tilted nearly 90 degrees. Okay, Uranus is tilted nearly 90 degrees. So Earth rotates like this, Uranus rotates like this. So basically it is rolling on its orbit around the sun. And it rolls and moves. And it's like a rolling drum. So that is the most peculiar feature of Uranus. What about Neptune? Neptune is the last planet of the solar system. Of course, Pluto hai, but that is no more planet. That is dwarf planet. I'll talk about that tomorrow. Okay, Neptune is the farthest most, and this is the only planet which is not visible to the naked eye. You cannot see the Neptune in the naked eye. You should use telescope. Its size is bit smaller than Uranus, thoda sa. Okay, it's not nearly twin, but like you can say almost thoda sa hai. That is Neptune. ये क्या हो गया? Natasha is asking, Earth is near to the sun as compared to Jupiter, so how come it is small in size compared to Jupiter? Yes, that is the reason. That is exactly the reason that it is small in size. Why the planets which are near to the sun are small in size? Because they are made up of rocky elements, more dense elements. They are more compact. इसलिए कॉम्पैक्ट होके वो छोटा हो गया है. Okay, maybe the earlier earth was bigger, gaseous elements tha, but all the gaseous elements were washed away. And all of them have become bigger planets in the outer circle. है ना? They are small because these are all rocky, very dense. यहाँ पर gaseous elements बहुत कम है. Fine, that is the same reason. Now I have two more things to tell. One is rotation, another one is revolution. Revolution of all the planets are from west to east. All the planets revolve around the sun in the same direction. They revolve in west to east direction only. There is no difference in that. Okay, सारा इसी direction में जाएगा. क्योंकि that is how it is said the entire nebula has been formed. And all of them are in the same direction of revolution. Rotation, not all of them. What is the direction of rotation of Earth? West to east. The direction of rotation of Earth is west to east. That's why we see the sun rising in east and setting in west. Sun rises in east and sets in west because we are moving in this direction. You might have heard if you want to refer to impossible task, impossible कुछ होना है तो क्या बोलते हैं आप? That will happen on the day sun rises in west. है ना? So such thing will happen in two planets. One is Venus, another one is Uranus. Both Venus and Uranus rotates in the direction of east to west. So basically both in Venus as well as Uranus, the sun rises in west and sets in east. Their direction of rotation is in opposite direction, which we call it as retrograde rotation. Retrograde rotation means rotating in an opposite direction than the normal. All the planets rotate from west to east including the Earth, but Venus and Uranus rotates in opposite direction, that is east to west, which is retrograde rotation. I have one last thing. The distance between sun and earth, is measured as 1 unit of distance, and that is called as astronomical unit. You might have heard about this. What is astronomical unit? Astronomical unit is the distance between sun and earth. So this is also a measure of distance. So this is important because we have life on the earth. With respect to any system of star, any planetary system, as per our current understanding of life, life is possible to exist only in certain distance from the sun. And that distance at which there is a possibility of existence of life, because if it goes too near to the sun, it is too hot. And the water cannot exist in liquid form, it gets evaporated very easily. If it goes too away from the sun, water becomes frozen. Again it cannot sustain in liquid form. And where did the life originate on the earth? In water. That gives the condition suitable for the origin of life. Water में ही होगा. So there should be existence of water in any planet for the life to origin. Now life to origin, as we know, of course, we don't know with any other form of life if it is there. So life can origin in only one particular zone in that planetary system. It should not be too near to the sun, it should not be too away from the sun. If it becomes too near, it becomes too hot. If it is too away, it becomes too cold. And that zone is called as Goldilocks zone. Goldilocks zone. So ये कहाँ पर यूज होगा? Suppose you are discovering new सोलर सिस्टम, न्यू स्टार सिस्टम, न्यू प्लानिटरी सिस्टम, कोई पास में कोई star को if you are seeing and their planets, of course every star would have its own planets. So if you want to search for life in those planets, you don't have to see all the planets. See only those planets which are located in the Goldilocks zone. Agar if there is a possibility of life in that entire system, it is only in that particular planet. So this is very useful in solar exploration, space explorations, where you can search for life in all the different planets. That is what is Goldilocks zone. So this question was asked in UPSC once in 2015. The term Goldilocks zone is often seen in the news in the context of what? It is in the search for Earth-like planets in the outer space. We can find Earth-like planets in these Goldilocks zones. Is that clear? So we have some more aspects of solar system to be covered. We will do that tomorrow, and tomorrow I will be starting with geomorphology also. Fine. Please revise and come. If you have any doubts, you can ask me in the beginning of next class. See you tomorrow. Thank you.